Hi guys, this video we're going to be learning about naming. So in chemistry, when we have two or more elements, we form compounds, and there's different ways that we name these compounds with their chemical formulas. And so different ways we do this. We have like type 1, type 2, type 3, type 4, type 5, and with these different types, there's different rules. So let's get started. So first we have type 1. So these have to deal with elements in the first two families, so right here, all the way to the left, and these are metals. And then it has to do with nonmetals, which are the elements like that are past this little staircase, we like to call it. And then it has to do with the three exceptions. So the ones in the boxes right here. So the three exceptions are aluminum, which is a +3 charge, zinc +2, and silver, which is a +1, which I put up right in this corner. So whenever we have any, and the exceptions are metals too. So whenever we have a metal and a non-metal bonding that are from any of these groups, we name them with these rules here in red. We do not use Roman numerals, we do not use prefixes, and we have the suffix "ide", and the metal always goes first. So an example of this would be MgF2, so magnesium fluoride. Notice how magnesium is the metal, and magnesium is right here on the periodic table. So it is a metal in the second family, and it is bonded with fluorine, which is over here, and it's a nonmetal, so it fits those two requirements. So we name it without Roman numerals and with no prefixes. So next we have type 2. So type 2, we have transition metals, so right here, and we have nonmetals. And it's important with type 2 that you only do transition metals and not metals in the first two families, and not metals that are the three exceptions. So it's not aluminum, not zinc, and not silver. And for type 2, we use Roman numerals to show the charge. This is very, very important. The Roman numerals show the charge, and they do not show the number of the amount that you have. And so for example, we have chromium 6 oxide. So oxygen, we know, has a charge of -2, and we have 3 of them, so that gets us a charge of -6. So then chromium has to have a charge of +6 to make it neutral, and that's why we have the Roman numeral of 6 to show that the charge of chromium is +6. This Roman numeral is not showing the amount of chromiums. It's only showing the charge of chromium. So that's the key point for type 2. Next, we have type 3, and these are two nonmetals. So nonmetals are the ones, once again, I've said this before, past the little staircase right here, and we use prefixes so to show the amount. So we have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca, and we use the suffix "ide". So N2O5, dinitrogen pentaoxide, so di meaning 2, penta meaning 5. Next we have type 4. So type 4 are polyatomic ions. So depending on which chemistry class you're in, you might have to know these on your own, like memorize them, or you might be given a sheet of these for a test or a quiz. But you can click here to see a video where we show a way that is very helpful in memorizing or knowing these polyatomic ions. But let's move forward. Right here are some common polyatomic ions. Notice they all have charges. But for naming these, you follow all the prior rules we just learned. So when you pair a polyatomic ion with an element that is like a type 1, so anything in the first two families or one of the exceptions, so things that we looked at in the type 1s, you follow the rule with the type 1s. So no Roman numerals and no prefixes. But if you pair a polyatomic ion with a transition metal, so stuff we looked at with type 2, you follow the rule with type 2. You use Roman numerals to show the charge of the metal. So you just need to pay attention with polyatomic ions to see what they're being paired with to then follow the rule with that. And also pay attention to the charges because the charges are not -1 for all of them. They could be plus, like ammonium, or they could be -2, like sulfate. Now let's look at an example. I put a periodic table here to help us out. So we have magnesium nitrate. So let's look at the chemical formula. So magnesium is right here on the periodic table. So it's in the first two, it's in the second family. So we know that it's kind of a type 1, so we're not going to use Roman numerals and we're not going to use prefixes. And it has a charge of +2. And we know that nitrate has a -1 charge. So if we have a +2 and a -1, we need 2 nitrates in order to cancel out the +2 charge. So we have a +2 and a -2. So that's where we get this 2 from. So then the name for it will be magnesium nitrate, since it's we're using the type 1 rule where there's no Roman numerals and no prefixes. So then we get magnesium nitrate as the name. Next example, we have lead 2 acetate. So the Roman numeral is showing us the charge because lead, which is Pb, is right here. So it's a transition metal, which means it's like the type 2. So we can use Roman numerals to show this charge. So if we have a +2, we're going to need a -2 to make it neutral, and acetate is a -1. So we need 2 acetates to cancel and make it neutral. So lead 2 showing the charge of Pb, and then acetate. And that's how we get this 2, showing that we need 2 of them to make that neutral. Next type we have is type 5, which is acids. So we have 2 types of acids, oxyacids and binary acids. So oxyacids is when we have 3 or more elements with an oxygen. So the rule with this is you add a hydrogen, which is a +1 charge, and you add AQ because it's aqueous. And you have to remember that the +1 of the hydrogen, you're always adding it to neutralize the charge of the compound. So if the overall charge at first is a -2, you want to add 2 hydrogens in order to have a +2 charge to neutralize that -2 to make it 0. And the next thing we want to look at is that if your compound at first ends with an "ite," your name for your acid is going to then change to an "us." And if your compound ends at first with an "ate," your acid will end with an "ic." So that might be kind of weird at first, but I'll show you in these examples. So C2H3O2 with a charge of a -1 is acetate. So look at the ending. Keep that in mind for later. So in order to make it an oxyacid, we have to add a hydrogen. So it has a charge of a -1, so we only have to add one hydrogen to make it neutral. And then we add the AQ, and then since it was acetate with H, it's acetic, we make it the ic, and then acid. And then let's do another example. So PO3 with a charge of a -3, that's phosphite. And then in order to make this an oxyacid, we need to first add the hydrogens to neutralize the charge. So it's a -3. So we need to add 3 hydrogens because hydrogens have a +1, so we have a +3. Then we add the AQ. And then since it was ite, it goes to phosphorus acid. Now, we have binary acids. So these are two elements without oxygen. And the rule for this is we add hydro to the beginning, and then we change the ending to ic, and then we add acid. So examples of this would be HCl, hydrochloric acid. So chlorine has a charge of a -1, so then you add a hydrogen because it's +1, and then you name it hydrochloric acid. And the same thing with hydrofluoric acid and hydrobromic acid. So that's the end of this video. I hope these naming tricks helped you out. If you need more practice, there are lots and lots of practice sheets in the chem modeling folder. My best advice for you is the more you practice with naming, the easier it gets. It really is practice makes perfect. So I hope this video helped you out.